Hi guys, so today we are doing section 9.6 out of the Green Book. This is a section very crucial that we skipped, but we happened to not have enough time right before break. So we're going back to graphing linear equations, actually linear inequalities, and the one section we missed, which was page 423, 1 through graphing systems of inequalities. All right, so when starting my class this morning, I did a show of hands and I said, how many 13-year-olds do we have in the audience? And I had about 15 people that raised their hands. And then I asked how many people were born in January. And we got about 5. And altogether, when I looked and I said, how many are both 13 and born in January, we had 3. And so that 3 is basically what we are looking for. We are looking for the intersection of the situation. Only we're doing it mathematically. And the intersection of the situation would mean that we have 3 total people. Okay, right in here, this area. So we're going to do that on a number line. Okay, so we're going to have 2 inequalities. So the first thing we're going to do is, I usually like to separate them. You have to identify, I think the easiest way to graph a line is by identifying their M and their B. Okay, so my M for the first inequality is, my M is 2, my B is 3. Remember, I'm going to start at the B at 3 on the y-axis. And then my M represents a rise over a run. So that would be 2 rise, 1 run, or 2 up, 1 to the right. Okay, so I'm going to go 2 up, 1 to the right. Or I can go -2 over -1. Right, down 2, left 1. Now, because this is an inequality, when we have an inequality, it's either solid or dashed. And if we have less than or equal to or greater than or equal to, it would be solid. And if we have less than or greater than, it would be dashed. And since this one is less than or equal to, it's going to be a solid line. Okay? All right. Now, shading. I like to do my shading. You could pick a test point, remember? If you pick 0, 0, substitute it in. If it makes a true statement, then that's the side that you shade. If it makes a false statement, then you shade the other side of that point. But I like to just actually look at this. Let's look at the y-intercept. The y-intercept means when I'm looking at the y-intercept, x is equal to 0. So if I'm doing y is less than or equal to 2x plus 3, and I substitute, I'm still doing this same problem, and I substitute it y is less than or equal to 2 times 0 plus 3, that really simplifies to y is less than or equal to 3. So I look over here. Where are the numbers less than or equal to 3? Here's 2, here's 1, here's 0, here's -1, here's -2, here's -3, here's -4. So where are the numbers? And here is +4. Okay, so where are the numbers less than or equal to? Just on the y-axis, that's all I'm looking for. Where are the numbers less than 3? It would go below that point, that y-intercept. So below is where I shade in all the way across. Okay, so I'm going to shade down. All right, so for the next one, I have to get the y alone, so I'm going to divide by 2. And then my M is 1/2, my B is -1. And now I'm going to start at -1. I'm going to rise 1, run to 2 to the right. Going up 1, 2 to the right. Or I can go down 1, 2 to the left. Because it's greater than, it's going to be dashed. And because it says y is bigger, like if we pretend that x is 0 and it zeroes us out, y is greater than -1, it's going to shade above this -1. So we're going to make that a dashed line. I usually like to do this in 2 different colors, right? I'm going to make my shading in this color. It's a good thing to do, like, okay, and then I'm going to do this. Here's my shade. Going through those points. And this says we're going to shade above -1. So here's -1. Here's 0. Here's 1. Here's 2. So I'm shading all of this. Now my solution is this double shaded part right here. And I'm going to write a little arrow and say this is the solution. So the solution is every single point in this double shaded area. Not the blue alone, not the red alone, but the double shaded area. Okay, I'm going to outline it. I don't want you to outline. I want you to do an arrow. Because if you outline, then I can't see if your line is... So anything inside the yellow area ends up being the solution. That means any point, what we're looking for is a solution to this system. That means any point within that shaded area will make this a true statement and this a true statement. 0, 0 works, right? So 2 is greater than -2. That would be 0 is less than or equal to 3. Okay, that's what that simplifies. So any point within that area, even the decimals, will work. Okay, so there we go. So here's how it looks on here. My PowerPoint is a little bit off. It's not usually black, but it's that double shaded area. We shade the whole side for this equation. We shade the whole side for the second equation, and then the area of intersection is the solution to the system. If you just try and shade the solution, it's too hard to figure out. So make sure you shade both. Don't go for just the solution. Shade the one, shade the other, and then the area of intersection is your solution. There's no thinking involved. All right, pause the recording and try the next one on your own. Now let's check our work. For the first inequality, my m is 3 and my b is -2. So I'm starting at -2, and you should have a very steep slope of 3 units up, 1 unit over. And this is looking like it should have been a solid line. And then if I make this, if I look at this, okay, y is greater than -. Dale, I'm recording. I need it to be quiet right now. Y is greater than or equal to -2. So where are the numbers greater than -2 on the y-axis? I would say here's -2. Here's -1, here's 0. These are the numbers. So where they're greater than is on the opposite side of the line, right up here. That would be your area of shade. I would definitely be shading it a little cleaner so I can really see it. If I weren't on it, and we are going to shade up. I have to pause it. Okay, let's take a look at the next one. My m is -2/3. My b is 2. I'm starting at 2, and I'm going to go down 2, right 3. Down 2, right 3. Or I can go up 2, +2, left 3. And this is going to be a dashed line. Okay, now, y is less than 2. So if you look, here's where I'm going to my y-axis. Here's 2. Here's 1. Here's 0. Here's -1, this is where the numbers are, so that is the area that gets shaded, this whole side of the line. Okay? And the area of double shade is the solution to the system. Okay? It should look like this. All right, let's try another. When you guys graphed single variable, these are like either horizontal or vertical lines. I generally taught you to make a table. When you get something that's like y equals 3, you're making that table that y is always 3, 3, 3, 0, 1, 2. And then you plot those points, 0 across, 1, 2, 3. Oh, 1 across, 3, 2 across. And we can see that it is making a horizontal line, and it's going to be dashed. Okay, you could have also done y is greater than 3, it's m is going to equal 0 and b equals 3. Remember what makes the x disappear. Or you can do it this way. I don't care what you're doing as long as you identify a way. And now it says y is greater than 3. So on my y-axis, since this is 3, where's greater? On the y-axis that it would get shaded would be above. Okay? Now try the next one. Now we've got y is less than -2x, so my m is -2, my b is 1. So I'm starting at 1, and now I'm going to go down 2, right 1. Down 2, right 1, down 2, right 1, down 2. Or I can go +2, up 2, left 1. Just take the negative there. And this is going to be a dashed line. And then I'm going to be shading, if I get rid of this, y is less than 1. Well, here's 1, here's 0, here's -1, here's -2, -3, so it's below that line. Okay, we're going to do below the line. A lot of times kids will use 2 different colored pencils, like blue and red. You should do complementary colors, blue and red, you know, red and green, blue and orange, pink and green, things like that. But your area of solution for the system is right here. Okay, I guess I should put it like that. All right, so sometimes we get the equations, and I'm going to remind you they're not in slope-intercept, so get them into slope-intercept. We got to get the y alone, so we subtract x, and then I divide all terms by 2. That means I like to show my kids doing it this way. Divide all terms by 2, by 2, by 2. So y is less than negative, this is a 1 over 2x plus 5 over 2. Or we could say, so my m equals -1 over 2, my b equals 5 over 2, or 2.5. So I can plot that in the middle. Okay, I can plot that. So I go to my 2.5. And now I'm going to go down 1 whole unit, down 1 to the right 2. Right in the middle of those boxes. Down 1 over 2. I can go up 1 over 2. Up 1 over 2. Okay, and I am going to draw a line. I'm going to draw a line, and this one should be dashed. Okay, now which way do we shade? Well, if I set x equal to 0, we say y is less than 2.5, so it would be less than would be underneath. Okay. The next one, we're going to do the same thing. Get the y alone. Subtract 3x. Now, very important that you're paying attention. We have to divide all terms. We have to divide all terms by, oh, not 2, by -1. When we divide by a negative, what it does is it flips the inequality around, right? I guess I should have done it right here. Okay, it's flipping the inequality around. And so I would get the opposite of y is less than or equal to negative divided by a negative here is a positive. This is positive divided by negative is a negative. And so my m is 3, my b is -4. And then we plot that point. So I'm going to -4. And then I'm going to go up 3 over 1, up 3 over 1, up 3 over 1. It should be a solid line. And now I'm looking at y is less than -4. So less than -4 would be here. So that would mean everything attached to that point. And so now you can see that your solution is right here. Okay. All right, let's try the next one. All right, we can do this with 3 different equations. I generally, when I have single variable, I make a table, So I've got y is always -2, -2. I can do the other one here. X is less than 3, and we do x and y, so it's 3, 3, 3, 0, 1, 2. 1, 2. And then the other one we can just plot. So let's start with it. We're going to do 0, -2, 0 across, -2, 1, 2. Oops. Okay. We're doing that, and 1 and 2, and we see it's a horizontal line, and because it's less than, it's dashed. And it's where we're going to shade is above the -2 on the y-axis. So that's getting shaded here. When I do the x and I plot the 3 points, so when x is 3, 1, 2, 3, right, it's going to look like this. And this is dashed. Okay, this says x is, we have to look at the numbers on the x-axis. So here's -2. I'm sorry, here's 2. Here's 1. So it's everything to the left of the line because that is what's less than. And now we're going to do our third one, which is x minus y is greater than or equal to -1, and so I'm going to subtract x. -y is greater than or equal to, sorry, that's weird, greater than or equal to -x minus 1. I have to multiply or divide everything by negative. I'll just divide by -1, forget that. Divide by -1 and -1. And we get y. We have to flip it around. Less than or equal to x plus 1. So m equals 1 and b equals 1. Okay. And so I'm starting at 1, and I'm going up 1 over 1. Now, this should be a solid line. And then it's saying that we're looking at right here, y is less than the 1. So since the 1 is here. So you should really kind of have 3 different colors in this situation. And the area of intersection is right here. I kind of like it better when we do it with my three colors. Let's try it. So x is less than 3. I'll do the first one in red. And that will be y is greater than -2. So that's here. This whole thing. It's a little bit easier when you have a... Okay. And then the next one was, let's keep that one black. X is less than 3. And then I'm going to do the last one will be in blue. Okay, and so here is the line, and it says y is less than. Or you could actually, let's make it a diagonal so it's going a different shape, a different direction. I have one already that's going. And now you can see there are 3 versions of lines. So my area where all 3 is here, here. So area of solution is right here. Okay? All right, so that's how it should look. Funky PowerPoint's freaking it out right now. All right, when we're writing our systems, it's pretty easy looking at the graph. You just have to figure out what the equations are. So this is a vertical line, and we know, I'm just going to pick some points. So this point is 1, 2, 3, -3, 0, -3, 1, -3, 2. So that's going to be, since x is constant, x is it greater than those numbers on the number line on the x-axis? This would be -2, -1, 0, 1, 2. So the shading for this point is above the -2. X is greater than -2, and it's dashed, so I'm just leaving it at that. The next one is right here. I'm going to make a table. So that's 2, 2, 0. That's 2, 1. So this one's going to be x is less than or equal to, it's solid, 2. Sorry, this should be 3. That should be 3, not 2. Okay. And so this is my system. Okay. If I have something like this, the first equation, we have to find the m and the b. So the b is 1, and my m is 2 over 1. So this is going to be a y equals 2x plus 1. It's solid, and it's shading. If I have to continue it. Okay, I have to continue it. So this shaded above, so this would be y is greater than 2x plus 1. The other one, I have to continue the shading, and I'm going to see my m is here. It's -2. No, my b is -2. And my m is negative. It's an up 1, left 1. So it's -1. So this is going to be y equals -x minus 2. But we need the symbol. It's shading, the numbers that it's shading on the y-axis are below that -2, so it's going to be y is less than negative x minus 2, and it's dashed. And so here is the system. Here's the system here. So it would be y is greater than 2x plus 1, and y is less than negative x minus 2. So that's how we would write it. Okay? So that's really our lesson. I've got a few more that you can practice with. And so here we are. That's about it. So just remember, when we divide by a negative to get that YLM, we have to flip the inequality. Very important. I've got two more that you can practice on. Pause the recording and try it. Now check your work. You should have gotten. And that, my friends, is our recording for the day. Have a great day. Please stay safe. Good luck with everything. Let me know if you're having any problems or if there's any issues. I have no problems. We're wrapping this year up. Okay?